In this lesson, you will learn to find the slope of a line, to graph a line given its slope and a point on it, and to interpret equations in slope-intercept form. Now, as we begin, we first need to know what does slope even mean. So a very basic definition of slope would simply be the steepness of a line. So a line maybe like this is pretty steep, so that would have a lot of slope. So the more steep it is, the more slope that it has. And a line maybe like this would not be very steep, so we would say that there's not much slope with a line like that. Now there's different types of slope that we're going to deal with. We first have positive slope, which would be a line that looks like this. Okay, so a line going up in that direction is going to be positive slope. Negative slope would be going down in this other direction. So that'd be negative slope. And then a vertical line would have what's called undefined slope. So you see here a U for undefined. And then you have what we call zero slope, and that would be a horizontal line. So the zeros are for the zero slope. And notice what we have here. We have a mnemonic, a way to remember the different types of slope, and we call this Mr. Slope Guy. So hopefully this will help you remember which slope is which. Now it's not enough just to say, that something has a lot of slope or a little slope. We want to know exactly how much slope something has. So to do that, what we do is we take the rise over the run. So the question is, what do we mean by rise and run? So let's take a look at an example. Here we see a line, and the question is, what is the slope of this line? Well, let's say we start here at this point, and we ask ourselves, okay, to get up to this point up here, how far to the left and right is it going? And then how far up and down is it going? So if you can imagine drawing a line like this right there, it's kind of hard to see, but this line right here in red, and you see how far does that go? Well, it goes over 1, 2, 3, 4, 5, 6, 7, 8. So the length of this segment is going to be 8. And then we draw another segment up to that point. So the question is, how long is this segment? Well, we go up 1, 2, 3. So the length of this would be 3. So notice the rise would be how high up it's going. That would be this 3. It goes up 3, and it's going over to the right 8. So the rise would be 3, the run would be 8, so the slope would be 3 over 8. So we can count like this if we need, but it's better to have a way where we don't need to count every time. So given the same formula, rise over run, and given the same picture, the question is there a way where we can find the rise and the run without needing to count every time? Well, notice that these points are at 1, 1, and -7, -2. And so the question is, how do we find this vertical length and this horizontal length? Well, the vertical component, up and down, that deals with the y values. So if I notice the y values for the ordered pairs, the 1 and the -2, if I subtract 1 by a -2, notice what I get. 1 minus a -2, so 1 minus a -2, that's going to give me a +3. And notice that is the length of this vertical component. That would be a 3. And then same thing with the horizontal line right here. Horizontal is dealing with the x values. So if I look at the x values for the ordered pairs, so the 1 and the -7. if I take 1 minus a negative 7, notice I'm going to get a positive 8. So the length of this segment is going to be a positive 8. And that is going to be the shortcut. Instead of needing to count every time, if I have 2 points for the rise, all I do is I subtract the y values, and then for the run, the left and right direction, I just subtract the x values. And that is what this notation means. So this is not y squared and x squared, but this 2 and the 1 are subscripts. It's just saying that you have your second y value subtracted by the first y value, and then your second x value subtracted by the first x value. So if you use these points, what you get would be 1 minus the negative 2 for the y values for the rise, and then 1 minus negative 7 for the run, which is what we just did. So when we do that, we're going to have a positive 3 over positive 8, and that is my slope. Now let's try another one. Let's say we had 2 points, 3, 2, and then 4, 6. And we're trying to find the slope of a line that goes through those 2 points. So the objective is to do this, to find the slope without needing to graph. So what I can do is I can use that formula where we find the rise over the run, which would be using y2 minus y1 over x2 minus x1. So when you use these points, let's say this is point 1, and this is point 2, what we do is we take the 3, call that x1, this would be y1, this would be x2, this would be your second y value, y2. And notice, if this is point 1, then this would be x1 and y1. If this is point 2, then this would be x2 and y2. It does not matter which point is which, as long as these numbers correspond. So if this is point 1, then you have a 1 and a 1 here. If this is point 2, you have a 2 and a 2 here. And at some point, you will not need to write all of this out, but it's sometimes helpful as you learn to maybe write this out so that you don't make careless mistakes. So when I solve this, what I do is I take y2 minus y1. So we have 6 minus 2 for the rise. And the run is going to be 4 minus 3, which is going to be 1. So what we have is going to be 4 over 1, or our slope is going to be 4. Let's try another example. Here we see a line goes through the points negative 3, 4, and then 5, negative 2. And so if we use our formula, where we take y2 minus y1 over x2 minus x1, we can find the slope. So just for illustration, let's call this one point 2 and call this one point 1. So I'm illustrating the fact that it does not matter which point is which. This can be point 2 if we want, and this can be point 1 if we want. So if this one is point 2, this is your x value, so x2. This is your y value, so y2. And then here we have x1 and y1. So notice the numbers correspond. If this is point 2, then this would be a 2 and a 2. If this is point 1, this would be a 1 and a 1. So if I do it this way, I take y2 minus y1, so I have 4 minus a negative 2 over, and then it's negative 3 x2 minus the 5 x1, which gives me 6. 4 minus negative 2 is a positive 6, and then negative 3 minus 5 is a negative 8, which can reduce, and you get negative 3 over 4. And on the slide, I have it the other way, where I'm showing that here I get negative 3/4, but if I switch this so that this is point 2, so this is point 2, this is point 1, so we just switch the order of our subtraction. If we do that, we're still going to get the same solution. So instead of taking 4 minus negative 2, I could do negative 2 minus 4. And instead of doing negative 3 minus 5, if I switch it, it'd be 5 minus negative 3. When I do this, I'm going to have negative 6 for the numerator. 5 minus negative 3 is a positive 8, which would also reduce to be negative 3/4. Notice it does not matter the order in which I subtract, as long as these numbers, the 0.2, 2, 2, and the 1, 1, 1, all correspond. Next, we're going to learn how to graph a line that goes through a point and with a particular slope. Well, we know how to graph a point. So a point, this point 0, 2, we can graph very quick because 0 is your x value, 2 is your y value. So 0, 2 would be in the x direction 0. X is left and right, so it's going over 0. And then y is 2, so it's going to go up 2. So that point would be right there at 0, 2. And then the slope is given to you as 1 over 2. By the way, we use the letter m to represent slope. So the slope would be 1/2. Well, we learned that slope is rise over run. So rise means up and down, run means left and right. So here the rise is 1. So what we can do is we can find another point so that we can then have 2 points where we know we can just connect the dots to create the line. So the rise is 1, so from this point right here, I go up 1. And then the run is 2, so I'm going to go over in the positive direction 2, which takes me right there. And notice I'm starting from this point right here. I'm not starting from the origin, I'm not starting from some other location. I'm starting from right here at this point, going up 1, and then to the right 2. So I just connect the dots, and the line that goes through that point that has a slope of 1/2 would be right there. I'm going to show you 2 more examples. Here's another one where your point is negative 1, 2, and your slope is 3. So negative 1, 2, we know how to graph this. This is x, this is y. X is negative 1, so I'm going to go in the negative direction on the x-axis, which is going to be to the left. And then y is up 2, positive 2. So I go to the left 1, up 2, to get that point right there. And then the slope, remember this is slope. The slope is 3. Well, remember slope is rise over run. Well, here, there is not a fraction given to you. It's just the number 3. But, as we know, if it's just a number like this, we can write any number as being over 1. Because 3 divided by 1 would still be 3. It does not change the value of that number. So what we have is actually a rise of 3 and a run of 1. So rise is up and down. It's a positive 3. So it's going to go up in the positive direction. So up positive 3 from this point. So up 1, 2, 3. And the run is 1. So it's going to go right over here where the run is 1. So that point would be right there. And then connect the dots. And that would be your line. By the way, another question that could be asked is if the slope is a negative 3. So what if the slope is a negative 3 going through that same point? So going through here, this point here, a slope of negative 3. Well, once again, rise over run is our slope. And we can write this as a fraction, negative 3 over 1. So if it's a negative 3, the rise would be down 3. Rise is up and down. Negative would imply that it's going down. That's the negative direction. So from this point, I go down 1, 2, 3, and then over in the positive direction, 1, because the run is a positive 1. So if it's negative 3 for your slope, you go down 3 over 1 and connect the dots, and you're going to get a line that looks like this. And then another common mistake that people make with this, with the slope of a negative, is many times people will think that the negative has to go with both the rise and the run. So they say, oh, well, negative 3, and so then they do negative 3 over 1, but then they don't know if the negative is with the 3, or if the negative is with the 1, or with both. Well, it's just with one or the other. And it really doesn't matter which one you put it with. It could be with either, but just make sure that you're not putting it with both. If it's negative 3 over negative 1, it would become a positive 3, which would be back to this other slope. And I do want to show you, though, that negative 3 over 1 would be the same thing as 3 over negative 1. If we do it this way, put the negative at the bottom, you have rise over run. And here, the slope is still negative 3, but the rise is positive. So if the rise is positive, from this point, I'd go up 3. So rise is up and down. It's a positive, so I go up 3. 1, 2, 3. And then the run is negative 1. So the run is negative 1, so which means I'm going to go in the negative direction, left and right. So negative would be to the left, so I go to the left 1, which takes me right here to this point. And notice I do have another point. It's a different point, but it's still going to be the same line. The line is going to go through the same points. It's going to be the same line. So it does not matter if the negative's with the top or the bottom. You'll get the same line. 2 different points maybe, but you'll have the same line. Let's show you one more example where the slope is going to be 0. So we can graph the point 2, negative 3. So we go to the right 2 and down 3 to get that point right there. And a slope of 0, remember with Mr. Slope guy, a slope of 0 would be something that's horizontal. So what we have is going to be a horizontal line going through that point. So your line would look like that. So up to this point, you've learned how to find the slope of a line by just counting. You've learned how to do it with an equation. And now I'd like to show you how to find the slope of a line if you're just given the equation of a line. And in addition, we'll learn also how to graph if you're given the equation of a line. So this would be the second way that we can graph. We learned in the previous lesson a way to graph by just plugging in values for x and y. In this part of the lesson, we're going to show you a quicker way to do that. So this is what we call slope-intercept form. What this is a form of an equation, a form of a linear equation, where if it's in this form, we can tell quickly the slope and the intercept. So what we use this for is we use this to graph quickly. So it's a quick way to find the slope and the y-intercept so that we can graph. So the format looks like this, where you have y equals mx plus b. M would just be the slope of the line, and m would be the number with the x. And b, the constant by itself, would be called the y-intercept, which is where it crosses the y-axis. So for example, let's say you're given y equals 2x plus 4. This would be in the format of y equals mx plus b. This number here with the x, the 2, would be your slope. The number over here by itself would be the y-intercept. So what we have is we have a point and we have the slope. So we can graph very quickly, just like we did a few moments ago. So the y-intercept is 4, meaning this is where it crosses the y-axis. The y-axis is the up and down line right here. And so if I go up 4, 1, 2, 3, 4, I get this point right there. So we have that point, that y-intercept, and we have the slope. The slope is 2. And remember, slope is rise over run. So we have the number 2, which we can write as 2 over 1. And so the 2 would be the rise, the run would be 1. So from the y-intercept, this point right here, the rise is 2, so I can go up 2, and the run is 1, so I go to the right 1. And I get that point right there. So my graph would look like this. So that is the beauty of this format. We can graph super quick just by looking at the equation. Here's another example where now we have fraction thrown in here. And notice it's still in the same format, where you have y equals mx plus b, where the number with the x is going to be your slope, so the 6/5 would be your slope, and the constant by itself is going to be your y-intercept. So the -3 is the y-intercept. And so what we can do is we can graph very quick, because the y-intercept is where it crosses the y-axis. So it's -3, so it's down 3. So we get that point right there. And then the slope is 6/5. So meaning 6/5 would be rise over run. So the rise is 6, run is 5. So I go up 6, 1, 2, 3, 4, 5, 6, and over 5, 1, 2, 3, 4, 5, to get that point right here. And then connect the dots, and we have this graph. So notice very quick once we have it in this format. Here's another example where now we have y equals 5/2 minus 2x. And be careful with this, because it is y equals, but it's not quite in slope-intercept form. Because slope-intercept form is y equals, and then the term with the x comes second, or it comes first, sorry. So the -2x should be first, and then the plus 5/2 comes second. So when you see it like this, we can tell a little more quickly what the slope and the y-intercept are. So the slope is always with the x value. So the slope would be the -2. So slope would be -2, and the y-intercept would be the number by itself, which is the 5/2. So now that we have the slope and the y-intercept, we can graph quickly again. Y-intercept is 5/2, or 2 1/2, same thing. So I go up 2 1/2, 1, 2 1/2 to get to this point. And the slope is -2. Remember, rise over run. So the rise would be -2, run would be 1. We could write this as -2 over 1. So from this point, we're going to go down 2. So 1, 2. And the run is +1. So I go to the right 1 to get that point right there. And then connect the dots, and I have this graph. Now the question is, what if it's not in this format? What if it's not y equals something? So let's say you had something like this, where you have x minus y plus 1 equals 0. Well, it's not y equals, so I cannot just say the slope and the y-intercept. I need to rearrange this so that it will be in slope-intercept form. Now there's two ways to get y by itself. There's a quick way and a longer way. I'll show you both ways, but I'll start with the longer way first. You need to get y by itself, so we need to get rid of the x, this negative, and the 1. So what I can do is I can maybe start with the x, bringing that over. So to get rid of the x, I subtract x, because x minus x would cancel, and over here I'd have a negative x. And then we need to get rid of the 1 and the negative. Well, we can get rid of the 1 pretty quick by subtracting. So when you subtract, you're going to get negative y equals negative x minus 1. And then we want to get rid of this negative sign. So this is negative 1 times y. So to get rid of the negative 1, I divide by negative 1. So negative 1 divided by negative 1 becomes a positive 1. And then divide everything over here by negative 1 as well. So what I have is going to be a positive y equals a positive x plus a positive 1. So basically, once you have the negative here, you just change the sign to a positive, change this to a positive, and change this to a positive. So now we're done. We have this in slope-intercept form, where it's y equals something times x plus the constant. Now another way you could have done that, and it's probably a quicker way, is simply bring the y over here to the right side. So what we could have done is just added y to both sides, and we could have gotten x plus 1 equals y. This would have canceled. I would have had x plus 1, which you could just put the y first. Y equals x plus 1, same thing. So either way, we get the same equation. It does not matter which way we get to it, as long as you get to that right format. And now as far as graphing is concerned, we can now find the slope and the y-intercept. So the slope is a number with the x value. So the slope would be an unwritten 1. If there's nothing written with the x, it's an assumed 1. So the slope is 1, and then this 1 over here is going to be your y-intercept. So we can graph very quick. Y-intercept is 1. So on the y-axis, we're going to go up 1 to this point right there. And then the slope is 1. So slope is rise over run. And the 1 can be written as 1 over 1, meaning you're going to go up 1, the rise is 1, and then run is 1, so you go over to the right 1. So from this point right here, I go up 1 over 1 to get this point. We connect the dots, and there is my line. Let's show you one more example where you need to rearrange first. So here we see 4x minus 3y equals 3. And by the way, this format here, when it's x and then plus or minus the y equaling a number, this is called standard form. So sometimes you'll see it in standard form, sometimes in slope-intercept form. We're not going to work with standard form much in this class, but I just want you to be aware of the fact that this would be considered standard form. So as far as getting this into slope-intercept form, you want to get y by itself. So get rid of the 4x, get rid of the negative 3. So we can subtract 4x from both sides. And we're going to have negative 3y equals, and then 3 minus 4x, or negative 4x plus 3, same thing. And then get rid of this negative 3. This negative 3 is being multiplied by y. So to get rid of the negative 3, I have to divide by negative 3. So negative 3 divided by negative 3 will cancel, give me a positive 1. And then divide this by negative 3 and this by negative 3. So what we have is going to be a positive y equals a positive 4/3 x. And then 3 divided by negative 3 becomes a negative 1. So for graphing, our slope is the number with the x value. So that's going to be the 4/3. And then your intercept is going to be that negative 1. So to graph, the y-intercept is down 1, that point right there. And the slope is a positive 4/3. So remember, rise over run. It's a positive 4, so from this point I go up 4, 1, 2, 3, 4, and the run is 3, so I go over 3, 1, 2, 3, to get to this point right there. And then connect the dots, and you get this graph as you see right there. And that concludes this lesson for today, and we will see you next time.